Welcome to Learning with Philemon. In this video, we will be looking at limiting and excess reactants in stoichiometry calculations. In the previous videos, we have been looking at reactions in which we have equal amounts of moles of each reactant. In this example reaction, A reacts with B to form AB. If we react 1 mole of A and 1 mole of B, there are no limiting or excess reactants. We have equal amounts of both and would form 1 mole of AB. All of the reactants are used up to make the product. Let's consider the scenario where we react 1 mole of A with 2 moles of B. A and B both have a coefficient of 1, so there's a 1-to-1 ratio between the reactants. 1 mole of A reacts with 1 mole of B, forming 1 mole of AB. This means that there is 1 mole of B left over. There is no more of A for B to react with. In this case, B is the excess reactant and A is the limiting reactant. Another way to think about these concepts is taking an example from baking. We need the following amounts of each ingredient to make 1 cake. Let's say we have the same amounts of each ingredient, but 300 grams of flour. We can still only make 1 cake as we don't have enough butter, sugar, or eggs to make 2 cakes. There will be flour left over, so that would be the excess reactant. The rest of the ingredients are the limiting reactants. Now let's look at an example that involves stoichiometry calculations. In this reaction, 2 grams of calcium, Ca, are reacted with 1 decimeter cubed of oxygen gas, O2, to form calcium oxide, CaO. To determine the limiting and excess reactants, we must first calculate the number of moles. To calculate the number of moles of calcium, we must divide the mass by the molar mass of calcium. There are 0.05 moles of calcium. To calculate the number of moles of oxygen, we divide the volume by 24 decimeters cubed per mole. There are 0.04 moles of oxygen. It may seem that there are more moles of calcium, so it must be the excess reactant. However, you must always take into account the molar ratio. There is a 1-to-2 ratio between oxygen and calcium. 1 mole of oxygen requires 2 moles of calcium to react, so 0.04 moles of oxygen requires 0.08 moles of calcium to react. We have less than 0.08 moles of calcium. This means that calcium will run out before oxygen. Calcium is the limiting reactant, and oxygen is the excess reactant. We can also calculate how much oxygen will be left over. 0.05 moles of calcium requires 0.025 moles of oxygen. To calculate the moles remaining, we subtract the moles available by the moles required. Substituting in the values, we get the following calculation. There are 0.015 moles of oxygen remaining. To calculate the moles of product, you must always use the moles of the limiting reactant. This is a common mistake made by students. There is a 2-to-2 ratio between Ca and CaO. Therefore, 0.05 moles of calcium would produce 0.05 moles of calcium oxide. To calculate the mass, we multiply the moles by the molar mass of calcium oxide. 2.8 grams of calcium oxide are formed. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.